So, about to show you this video for the inspection. Keep in mind that it's just the major stuff that's a little difficult to explain in a report. So your report's going to have more detailed information and things that aren't going to be in this video, so it's important to look at that too. So it looks like at one point you had some visual mold growth. You see that spotting in between the air handler system and the wall. This is most likely because these air handlers, these little cracks and stuff like that, they're just leaky and they have cold air coming out and they're cold themselves. And then you have a hot wall. This is your exterior wall. So hot and cold meet, you get condensation. So this is liable to happen whenever you have your air handler in the garage or anywhere that's not conditioned. So just keep in mind that this is prone to occur. So this is the bonus room above the garage. You'll notice that this room is most likely going to get a little more stuffy, a little warmer than the rest of the house in the summer. And this is because, one, it's above the garage, and the garage isn't conditioned. It gets super hot in the garage. So all that heat rises and comes into the home right here in this bonus room. Also, you notice there is a return that sends air back to the unit, and then a supply vent that brings cold air in. They're very close to each other, and so what can happen is something called short cycling. So when this air comes out that's nice and cold, it's going to get sucked right back into the return. So you're not really going to get a lot of cold air happening on the rest of the room. You only have this one little vent here. The other thing that you'll notice that's going to make this place a little warmer is on the other side of this wall, and on the other side of this wall is attic. And so that attic air is going to constantly try to come in. Hot always wants to go to cold. You'll also notice here that this is your attic door. And if I just put my hand here, I can feel hot air just coming on in. I have a smoke pen. I don't know if you'll be able to see very well in the video. This tells me which way the wind is going. If I blow it in this crack, you can see it's coming right back. So constantly, and this room could probably get much more humid than the rest of the house. And if you don't use it often, it doesn't get a lot of airflow. You have stuff stored up here, humidity's climbing, you don't check on it, you could get mold growth. The other thing is this wall, like we were mentioning, see, is an attic wall. And it's very important that the insulation is flush and sealed to the wall. And as you can see, there's some missing parts. And right here, I'm gonna superimpose another video of what the wall looks like on the other side with a thermal imager. All that warm section that you're seeing as I'm scanning around the room, that whole section is just areas where insulation is missing. Now, the problem with that is you could very easily get mold growth on the back of these types of drywall because that hot hits that cold and you'll get condensation. Another issue that you're going to notice in an area like this is because hot always wants to go to cold, because wet and humid always wants to go to dry, there's constantly going to be vapor driving into your house. It's very important to get these things air sealed, which is one thing, air sealed, and thermal barrier. The thermal barrier right here looks pretty good, but the air sealing could be done a little bit better. And that basically means just sealing with whatever it is, caulk, spray foam, around areas of penetrations throughout the envelope. This is what we would consider the envelope. Now let me show you an issue that's being caused by not having a proper air barrier. I pulled off this light switch, and as you can see, around the edges you have some mold growth. And that's because that hot air is coming in, and that humid air is coming in. It's hitting this wall, and right here where it's colder and they touch, it starts condensating, so you constantly have condensation. This is the back of the light switch. As you can see, it's got some mold growth. So you have a lot of windows in here. Beautiful, lovely architecture, brings in a lot of light. But you know what else that light brings in? Is heat. So you're gonna get that radiant heat popping through. And if you notice that this area is just a little warmer, then it's a pretty easy fix. You can wait until the windows start getting old and just replace them with more energy efficient windows with better UV filtering. Or you can go out and get some window tints, UV protection. Some of them aren't even really obvious, you can't really tell. And you just have it tinted out, and it's gonna increase the energy efficiency in here a lot. All right, I wanna give you a quick rundown on how the HVAC system works. So this is your return vent. So all the air in the house gets sucked into here. It gets sucked into there, going to the HVAC system, okay? And it's connected to this duct, so it gets sucked in, it goes up, it gets cold in the summer, gets cold, and now it comes back out into this duct cold. And then all the cold air comes out of your supply vents right here. You feel it blowing right now. And then that supply vent, once it gets sent out, it gets sucked back up into a return, goes back to the unit, gets cold, comes back out. It's a perfect circle. It's just circulating, circulating, circulating. You never actually get fresh air. That's one important thing. Most houses are like that. It's normal. So with that being said, what we need to do when we're blowing this out of the supply vent, we want to make sure that it can easily get back to the return vent. You have a return vent right here. You have one upstairs. And then you have one more. I haven't seen any more. These are the ones that I've seen. And then you have one more right here. So it can, the air blows out, gets sucked in, goes back to the unit, and it's able to easily circulate. But what happens when the door's closed? Now, the air gets blown in there, but how's it gonna get back to the return? It's gonna have a very difficult time making its way back to the unit to circulate again. So what can happen with these rooms is they can get a bit stuffy because that air isn't circulating. They could get colder, warmer, depending on the time of year. This is your master. So this is the closest return to your master. So if you're all the way over here, you have a supply, no returns, and this door's closed. If this room starts getting a little stuffy, or a little colder or a little warmer, you know why. Now, we have this really fancy tool called a manometer. Basically what it does is it measures the pressure inside the room and outside the room. So right now, we have this red little circle-y thing right there. That's measuring the pressure on this side of the room. And then I have a tube. As you can see now, it's 0 because it's measuring a difference. The tube measures wherever I have it. They're in the same area, so it's 0. So if I throw that tube in there and then I close the door, now I can measure the pressure difference between where I'm standing and where that is. And right now it's a difference of 4 pascals. So what's happening is that room is kind of blowing up like a balloon. It's got a lot of air pressure that's building up because it's blowing into it, and it has nowhere to go. So it's positive pressure right now. And what it also tells me is that the air that wants to get back to this return isn't really getting there like it should. Now the reason that's important is because these return vents are designed to have a certain amount of air going in. And so let's say if it's sucking 500 CFM, that's just an easy number. If it's sucking 500 CFM into this return, then 500 must come back out of here. It's gotta be perfect. If it's sucking too much in and you can't get any back out, what's gonna happen is it's gonna compensate for that and try to suck it in other places. So if it's sucking 500 in and it's only getting 300 from all the supplies, because some of them are blocked with closed doors and stuff, it has to pull that 200 extra CFM somewhere. And where it's gonna pull it from are your recessed lights connected to the attic, light switches that are in these little interstitial wall spaces. So you could have what's called negative air pressure pulling attic air, light switch air, which is still connected to the attic, outside through the windows, trying to make up for that extra 200. Now these are just example numbers. In our building science engineering analyses, we actually run through all these numbers. But this is just the general idea of what could be happening. Long-winded explanation, but what do you do about it? Well, one of the simple methods is you create like a little louver right here. You've probably seen them, where you have a little vent above the door, right? You have one right here as well. Sometimes you don't want those if you have kids and stuff. They're really loud in there. It can come through. So you also could turn this return into a plenum, and then you just put little mini ones on here. So you have a little mini return. Sorry, I just dropped my phone. So you have a little mini return in the ceiling right here, and then you have a little mini one right here. And they're all just little ducts that connect to this. So it can go directly into the return. So that's another good idea. This room right here, since it's a little further away, it's gonna be a little harder to run a return all the way back. So you could do what's called a jumper. So you put a return right here. It just has one little duct that goes like in a little U shape. So boom, whoop, boop, and then another one like right here. And so the air can easily get past whether the door is open or not. And since it's going into a duct and going through the attic, you don't have to worry about the sound or a nasty ugly hole being cut right here with a vent. So this is a tricky one. This corner of the shower with the infrared, you'll notice right there in the corner that darker spot. It's like a darker bluish purple. That could be an indication that that spot is just colder, because this is a thermal imager, but it could also be an indication that that spot is wet. So we want to double verify with our moisture meter. First, what we do is we take a baseline of an area nowhere near, 14.3. As you can see, green is good. And as we get closer, 99%. The limitation of this moisture meter is it works off of conduction. So if I'm hitting something metal, a metal frame, anything that could be conductive, this will give me a false reading. And if it's something like metal, then it would be, it doesn't retain heat very well, so it would be colder too. So we still 100% don't know if this is moisture. So let's go outside and take a look. So this is the wall right here where the shower is. That's where the tub is and the window above the tub. This is the area kind of where we're seeing it. And as you notice, there is some discoloration on this brick right here in this area. If we come over here, it looks perfectly fine. Now maybe it's because it's in a shaded area, this plant's retaining moisture, and it's just getting on the wall. Maybe it's backsplashing from an irrigation system nearby. There is a flashing right here. If these aren't done perfectly right, you could get moisture behind the wall. Here is an area where it's not perfectly sealed. And then a little bit around this window. Maybe it's a plumbing piping issue. There might be a pipe going through here because you have your shower, and then you have this as well. You also have the irrigation. Maybe there's a pipe underneath that's leaking up, and capillary actions bring it in. There's a lot of different things that could be happening. Unfortunately, during this investigation, I'm not a leak detector, so I can't tell you 100%. It's very difficult to know. I will say that when I pull this mulch back, it's pretty wet under here. And then over here, it's dry. Again, that could be something completely different happening. You know, it could be rain coming down. It gets diverted off and it just splashes. So it could be a complete false alarm. Now, in my report, I'm gonna think about it a little bit longer because I'm still on site. I wanna sit down and look at it, but I'll most likely recommend that a specialist come out, someone that actually handles moisture specifically, to take a look at this area and make sure, because that is gonna be a big cost difference if you need to pull the shower out to figure out if there's a leak. One more thing I'll leave you with. Keep in mind you're paying me to come in here and tell you all the problems that you have with this house. So it's easy to focus on the negative, and my report's only gonna have the bad stuff that I found. But the vast majority of what I tested was really good. There's really not a lot of widespread moisture issues. You know, the house was built well. The attic system seems great. The HVAC seems to be running properly. It needs a little work here and there, like we talked about with the pressurization. But all in all, it's a good home. And I don't want you guys, if you really love this home, to focus too much on the bad, because you're not gonna get a report on how great the house is. But, you know, if you're curious about any systems that aren't in your report that, you know, we most likely checked, feel free to give me a shout, and I'm more than happy to walk through all the stuff that I found that was good, because I don't want you to focus on the negative, right? This is a really nice house, and if you're excited to move in, don't be stressed out.